Hey guys, this is the MakeHaven badging video for the universal lasers. We're going to start by taking a look at Inkscape and setting up a file for cutting. We're going to walk through the machine and how to use it safely, and then we're going to actually cut a piece and get you ready to go. It all starts with Inkscape, which is a great piece of free vector software. You can find it on the computers throughout MakeHaven. If you're interested in using it, it is a free download. You can certainly put it on your home machine, and that will speed stuff up as you transfer files back and forth. It works in vector files. The difference between a vector file and what you would get in something like Photoshop or a JPEG file is that a vector file is all about points in space and the relationship between them, whereas a raster file is about a pixel by pixel accounting of data. So you can get a lot of detail into a photo, but when you zoom in, you start to see that that detail is really actually just an illusion. It's a pixel by pixel collection of this color here, that color there, that then when you zoom out looks like a face. A vector file, on the other hand, is a much more precise, almost mathematical mapping. You think of a circle, you've got 4 points, point 1, 2, 3, 4, and it's how you get from point A to point B. The relative distance, the way it curves, then point B to point C, C to D, and back again. What that yields is a file that the laser will be able to follow very closely because there's no little pyramid effect. It also gives something that we can scale and zoom in or out as much as we want to, because again, it's all about where this point is compared to that point. So we're gonna hop onto Inkscape here. We're just gonna make a real simple keychain today. We're going to start by creating a circle using the ellipse tool. Very simple to do. It looks like a circle, but if we want to check to be sure that it actually is a perfect circle, we can use this top arrow here. This is what I refer to as the select tool. We've selected our object, and if we look up here at the width and the height, we see that it's actually not quite perfectly circular. I'm going to change it to inches, just so it looks a little more familiar to me. And we see that we're at 9.5 plus inches by almost 9 inches. I can change my width and height both to 9, and now it is perfectly proportional. If I want to keep that proportion, I can use this little lock tool, and if I change this to 5, the height follows. Now that we've got this circle, we need to start getting it ready for the laser system to interpret it. In doing so, we're going to use the fill and the stroke and assign colors and conditions to the fill and the stroke that we apply. And the reason we're going to do that is the colors can be mapped to behaviors on the laser, either an etching behavior, which we will refer to as a raster, or a cutting behavior, which we'll refer to as a vector. Those colors need to work in absolute red, green, or blue values. We can also use the CMYK scale, but for now we'll stick with the red, green, and blue. RGB scales work in values of up to 255. So if we want to make our circle filled red, we change that value to 255 red, make sure that green and blue are both at 0, and we have a red fill. We leave this bottom one at 255. That's our opacity scale. Obviously, if it is less than opaque, it could cause problems later on with the laser. The next piece we want to work with is the stroke. This will be the outside line around the circle. So I'm going to click on the Stroke Paint tab. I'm going to apply a flat color. And in this case, I'm going to make that outside stroke green. Now we can't really see it right now because that outside stroke is at just shy of 0.3 of a millimeter. It's very narrow. When we're sending a cutting line to the laser, we want to use pixels, and we need to use a pixel value of 2/10 of a pixel or less, so 0.2 pixels or less. In this case, we're already at 0.110, but let's work with 0.2. The reason we need to use a very narrow stroke on the outside is that stroke has to be something that the laser can actually follow and that the computer can interpret as a path for the laser. It's not trying to decide should it follow the inside of the line or the outside of the line. It needs something that is narrow enough that it can run straight down the circle. So now we have our circle with a red fill and a green but barely visible stroke around the outside. And we can move on to something that we want to engrave on the inside. Right now, when we get over to the laser, that green stroke will be defined as a cut stroke, and we'll actually skip the red stroke. We're just gonna leave it there so we can see where our shape is, and we can make sure that we're recognizing everything in the relative space. So now that we have our shape with the red fill and the green stroke around the outside, there's one last step that we need to take to get this particular piece of our file ready to go for the laser. What we need to do is we need to take this object, which is currently a circle, and change it to a path. It's a very simple step. We just go to path, object to path, and we're done. Doesn't look like a big difference to us, but the computer will be able to translate it now on the laser. If we don't take that step anytime we've used one of the tools on the left-hand side of the navigation pane, the circle, the square, the text file, the laser will just ignore it when we get there. It will look like it's going to go, it will beep at you once, and then move on. So our next step will just be a very simple text. We're going to add NHV for our beloved MakeHaven. I'm going to take this up to 2.5 inches. We can place it on our circle. If we want to make sure that that is perfectly aligned, I can go to Object, Align and Distribute. I'm going to work relative to the biggest object, or I could also go relative to last selected, etc. I'm going to center it horizontally and vertically, and now our text is in the middle of our circle. I'm going to select the text again. I'm going to, as I did with the circle, go from Object to Path. And so now we no longer have editable text, we have editable shapes that look like text. I can tell that these have become editable shapes because when I mouse over them, it's showing me the nodes. The nodes are those points in the workspace that I mentioned earlier. I've selected them all just by holding the Shift key and clicking along. You can also do a click and a drag. I'm going to take a look at my fill and my stroke. Right now, it says that paint is undefined. That's going to confuse the laser a little bit, so we definitely need to give it some definition. We'll go with a flat color. In this case, we can leave it at black, which is a 0 red, a 0 green, and a 0 blue. We're going to go ahead and add a black stroke as well. And in this case, we'll just go ahead and set that stroke at 0. Sometimes getting rid of the stroke can be a good alternative. You could just do that by selecting no paint, but every once in a while a stroke with no paint will also throw an error on the laser as well. Now that we have everything looking the way we want it to, I'm just going to hit Control-A to select all. I'm going to move this all up towards the top left corner of my workspace. And the reason we want this in the top left corner of the workspace will make a little more sense when we get to the laser, but in short, the laser is going to be starting its work from the top left corner of our file. And if we know where our object to be cut, etched, etc. is on the file, it's a lot easier to place that point of origin on our work material on the laser. The last thing I'm going to take a quick look at is the display mode. I'm going to go from view, display mode normal, to outline. And this just shows us our vectors. If anything appears on here that doesn't belong, maybe you put an accidental tiny stroke in there that's going to cut into your object later on and ruin the project, or if something does not appear when you look in your display mode, it could be stuck at a raster file. Maybe you didn't convert a PNG that you were trying to bring in. That'll become apparent at this point. Everything looks good to me here, so I'm going to go ahead and save as. I'm going to save it as keychain NHV. And now I can get it ready to go. This is one of our universal lasers. It is a 60 watt CO2 laser system. We have 2 of these in-house. They are basically the same machine, although slight differences in use cycles, age, etc. may give you a slightly different result from one machine to the next. So always be sure to check out and test your file if you have been moving from one universal to another universal between cuttings. As a MakeHaven user, the #1 thing you can do to help take care of the lasers is to just be gentle with it. Always make sure that when you open the lid, you open it fully so it does not slam back down. Make sure that you close it gently. We take care here because the CO2 lasers are finicky and delicate, and if we smash this lid down or let it drop, it can jostle those laser tubes, which will over time lead to degradation of quality and ultimately necessitate a replacement. Using the MakeHaven universal lasers safely is an easy thing to do. The #1 thing we're looking out for is fire safety. Fire safety starts by staying aware of the machine. Here at MakeHaven, our rule says that you need to stay within about a 20 to 25 foot radius of the machine so you can keep an eye on your job at all times while it's operating. It means that if you need to take a step away from the machine to use the restroom, take a phone call, etc., you can either ask another member to keep an eye on the job for you, or you can pause it for a moment using the pause button on the front of the laser. Wait for the job to stop, step away, do what you need to do, and then press resume when you return. As we run a job, it's not uncommon to see flames. Very often that just means the laser is reigniting some of the vaporized material. But every so often, our laser moves to a different piece of the workspace and a flame stays put. That means our material is burning. That means we have a small fire that we need to deal with. There are several things we can do to take care of that. Again, we can pause it and try to salvage our job by putting the fire out afterwards. If your job is at this point irretrievably damaged, or it was a test cut, or if the fire is starting to spread through your material faster than you're comfortable with, the easiest way to stop it is to just lift the lid a little bit. This will change our cutting laser to a spotting laser. Very often that can be enough to take away the heat source. The other thing that this will do is this will bring in a sudden gust of wind. And if it's a small flame, it's kind of like blowing out a birthday candle, because there's a blower pulling air from the back of the machine through the front, as well as another blower that's evacuating the vaporized material from the building. If we've opened the lid a little bit and the flame is still burning, again, this is all about comfort level. If you feel safe doing so, you can try to blow it out. You can always use a fire blanket. They will be hanging on the front of the lasers. Rip it open, pull the blanket out, lay it over the burning material to smother the flame. If the fire blanket is for some reason unavailable, or if the flame has spread to a point where you feel like it is out of control or not manageable with the fire blanket, you can take the CO2 fire extinguisher off of the front of the epilogue laser in the back corner. It's labeled as carbon dioxide. It's also recognizable with this black cone. Pull the pin, stand back several feet, point it at the base of the flame, squeeze the handle, put the fire out. We use the CO2 fire extinguisher in this case because it's going to cause the least additional damage to a laser in putting out the fire. And we can clean it up and get it back in service a little bit faster. If for some reason the fire extinguisher is empty, exhausted, or otherwise unusable, there are additional fire extinguishers located throughout the space, including a chemical fire extinguisher outside of the wood shop and a water fire extinguisher in the kitchen. If you need to escalate to using one of those fire extinguishers in place, at that point it's probably a good idea to dial 911 and get assistance from the fire department and make sure that everybody in the space knows that we've got a problem. Beyond fire safety, material safety is another concern we have when we're using the lasers. That means we need to be cutting materials that are both safe for the people around the laser as well as for the machine itself. A general rule of thumb is that anything natural or organic is probably relatively safe. Some examples of safe organic materials to use would be paper, cardboard, wood, plywood. You can use the lasers to etch anodized aluminum. You can use it to etch glass. There's more details about the etchable and cuttable materials on the website. When in doubt, if something's not covered by the website, please be sure to do your research before bringing it into the space, and when necessary, consult with JR. Unsafe materials are those that are going to cause harm to the machine or be dangerous to the people around the lasers while you're using them. PVC is a prime example of this. The byproducts of cutting PVC with a laser can cause damage to the machine and are definitely toxic to those around it. Okay, it's time to cut our file. The power switch for the universal lasers is located in the back right-hand corner of the machine. It's an orange toggle switch that's pretty easy to find. Now that the machine is on, we're going to check out the optics and make sure that they're in okay condition to cut. If we take a look inside the universal, we can see the port where the laser comes into the machine. It hits a mirror in this housing, another mirror in this housing, before hitting the lens down here. In order to make sure that the machine is ready, we can just remove the thumb screws from the front of the lens plate. Take a quick look to confirm that the lens and the mirror have no significant defects and aren't dirty. In this case, they're both in okay shape. We can replace the lens housing. Making sure to put the screws in at least to finger tight, and now that's ready to go. If you need to clean the lens, supplies are located in the laser supply drawer. Using lens cleaning fluid and a microfiber cloth or lens tissue, just clean the lens very gently in a circular motion. Always apply the liquid to the tissue or the cloth, not directly to the lens. Clean sparingly, because we don't want to damage the lenses through over-cleaning. Since we're going to be cutting through our material, we're going to use a table that will allow the smoke to vent from underneath the material. This is an example. It's a honeycomb table. After opening the front of the machine, slide it gently in, taking care to make sure that the table is low enough that anything will clear our lens housing. We want to make sure that nothing can interfere with the motion front, back, side to side. This is situated against the guides at the back of the machine. I can close the front, place our material. In this case, I'm using a piece of scrap wood from the bin underneath the laser, and now that it is here, I'm going to focus the laser using this tool. This is a 3-sided focusing tool that can accommodate a 1.5 inch, a 2 inch, or a 4 inch focal length. You can identify the focal length by looking at the plate on the front of the laser. In this case, we are using the 2 inch. In order to focus the laser, I'm going to hit the Z button. Using the arrow keys, I'm going to locate the lens housing over the material, making sure there's ample room for my focusing tool. I'm going to place the 2-inch side of the focusing tool along the left-hand side of the lens housing. And using the up and down arrow keys, I'm going to raise the cutting bed until I see the focusing tool shift out of the way. That's how we can tell it's focused. Another adjustment we might want to make on the laser before running our job is setting the origin. We do that by hitting the XY button and using the directional arrows to place our starting point. In general, the machine will default to a starting point in the top left corner of the cutting area. On occasion, you may need to adjust this, or you may want to start somewhere else, for example, in the bottom right-hand corner of the material. In this case, I'm happy with where this is. I'm going to hit select to set new origin, and then confirm by, again, select on yes, set new origin. And now our origin and our position are the same. This laser dot is where that top left-hand corner of our file will begin. Now that the laser is ready to go, it's just a question of sending our file. We're going to do that by going to the extensions menu, selecting export and Win32 vector print. This will bring up a dialog window in which we can map our colors to behaviors, powers, etc. We use the pen mode on this menu to tell the computer and the laser how to interpret each color in our file. In this case, we want to etch the black NHV letters. So I'm going to click on the box to cycle through to rast or raster. We are going to skip the red in this circle. We're just using that for placement. So I will cycle through to skip. And then we're going to cut that fine green line around the outside. So I'm going to set that to vect. The fourth option is rast/vect. In that option, the laser will etch the object and then trace around the outside. It's the same effect that you can get if we were to select raster for the red and then leave vector on the green. With rast/vect, you do sacrifice some control because you're allowing the computer to optimize the power for each operation. Now that we have our pen modes set, we can set the power for each of our colors. For black, which we want to run a raster, I'm going to set the power to 50%, speed to 30%, and our PPI to 250, and hit the abnormally large set button. For our vector, I'm going to use 75% power, 4.8% speed, and again, 250 PPI, and set. These speeds, again, can be found on the MakeHaven Universal Laser Cutter webpage. We have a list of recommended settings for popular materials in the space. These are all considered starting points. You should certainly feel free to adjust them as necessary to get the desired effect. Another thing to keep in mind is that power and speed are inversely related to one another. A slower speed is similar to turning up the power because the laser is staying over each piece of wood just that much longer as it slows down. The PPI setting refers to the density with which the laser is firing at the material. A lower setting such as 250 is useful on a porous material like wood, cardboard, paper, etc., whereas a higher PPI such as 1000 really gets used on non-porous materials such as glass or acrylic. Now that we have our power and our pen mode set, we can double check that the image density is set to 5. This should always be set at 5 when you open this dialog. If by some chance it's not, you want to set it back to 5. If this is higher or lower, it will result in stretching or compressing of your file. So it is something to keep an eye on. The Advanced tab allows us a few etching options, optimizing a dark file for a dark surface, a lighter file, or in this case, keeping a black and white, sort of an on and off. This option allows you to control the print direction of your etching, either from the bottom up or the top down. This can be useful in controlling the way in which smoke or soot collect on the job if you're having issues with that. Now that everything is ready to go, we've double checked our powers, our pen modes. I'm going to click on the OK. The screen on the laser will display the settings for our first raster. It will always run the rasters before the vectors to make sure that the pieces don't drop out. Before hitting start on the laser, I'm going to make sure that the overhead ventilation is on by flipping the switch underneath the window. And now that that's running, I can hit the green start button. Now that our job has run, I don't think the laser has made it all the way through this particular piece of wood, which is a little bit on the thick side for cutting. I do, however, think our etch looks good. So in order to resend the job without re-etching, I'll switch black to skip and hit OK and send this to the laser again. As long as I have not touched the material or moved it in any way, the laser should be exactly on track with where it was on the prior job. Once the cut's complete, you can open the lid. Take pride in your work. If you've been cutting something like acrylic that can have a strong smell after you've been cutting, you may want to just leave it in the machine with the lid closed for another 5 or 10 minutes to make sure that that smell is dissipated before you take it out. Once you're finished, simply close the laser. Turn off the machine. Switch off the blower, close your files, and you're on your way.